Today, we want to talk about the difference between AC and DC. AC and DC. AC stands for alternating current, where DC stands for direct current. AC and DC, we've been hearing this. What are the differences between them? I'm going to differentiate between them through the following headings. Number one, alternating current. What are the sources? Where can we derive alternating current from? Alternating current can be derived, can be gotten from these sources through generators, our alternators. Then from our national grid, we can get our alternating current from it. Our direct current can be gotten from our electrolytic cells, battery, solar panel, photovoltaic cells, dynamo, and so on. Do you ask me what I mean by dynamo? Dynamo is a DC generator. If you don't know this, most of you have bicycles at home. Your bicycles, some bicycles have headlamps, and these headlamps, they are connected to the dynamo. Dynamo are situated very close to the wheel. So as the rider pedals, you notice the more the rider pedals, the brighter the headlamp of your bicycle. So it is because it is the wheel that is driving the dynamo of the bicycle. The higher the speed of the wheel, the higher the speed of the dynamo, which means dynamo is a DC generator. Dynamo is actually one of the sources of direct current. From our solar panel, we can get direct current. From our batteries, we can get our direct current. From photovoltaic cells, we can get our direct current. Then from dynamo, we can get direct current. Those are the sources of our direct current. Now, we've learned the sources of AC and DC. Now, what is another very significant difference between them? Let us study the way they flow. Alternating current, from that word, the word alternating, which means something that changes its position continuously. If it is here at this time, later in the next few seconds, it is like this. In another few seconds, it's like this, and so on. So it changes its direction of flow continuously with respect to time, and that is alternating current. That's alternating current. Alternating current flows continuously in a sinusoidal way, the way that it keeps changing its direction. If you look at it here, the alternating current, this is it. You can see it starts from 0 here. It flows and attains the maximum height. Later, it flows down again back to 0. From 0 to the minimum. Why did I call it minimum? In our graphs, in our graphical analysis, this side is the positive side and this side is the negative side. So the positive side is the maximum and the negative side is the minimum. So the alternating current flows from 0 to maximum, and from maximum back to 0, from 0 to minimum, minimum back to 0, 0 back to maximum, maximum back to 0, in that order. That is why we call it alternating current. Direct current, in the other hand, direct current is a type of current that flows in only one direction. It doesn't change its direction. If it is going to flow in negative sense, it is going to be in negative sense. If it is going to flow in positive sense, it flows in positive sense. It doesn't reverse its direction of traveling. And when you look at it here, look at this line. So that is direct current. It is flowing in positive sense here. That is why we label it as positive. And when it is flowing in negative sense here, it is labeled as negative. So which means another difference between them is that alternating current is not polarized. What do I mean? Any electrician, any engineer that you ask, that you tell about direct current or that you tell about alternating current, and he's telling you and the two terminals are positive and negative, just know it's not, just believe it is not, he or she is not a competent engineer or a technician. Alternating current does not have polarity. Rather, we rate them as a live and neutral, or phase and neutral, not as positive and negative. But direct current has polarity. Why does alternating current not having polarity? Let us look at it again. At this particular time, it is 0. And at a particular moment here, it is positive. Now, when you look at it again, 0. Now it is in negative. So its polarity keeps reversing. So that is why we cannot say it is positive permanently or negative permanently. So, but it is alternating. But direct current, if it chooses to flow in positive sense, it will remain in that positive sense and the negative sense. So that is why alternating current is not polarized, while direct current is polarized into positive and negative. Another significant difference between our alternating current and direct current is they are protected with AC breaker. If you are an electrician, an engineer, you want to buy circuit breakers to protect your current, you need to find out what type of current am I protecting. Is it an alternating type or the direct type? If it is on that alternating type, you are going to buy alternating current circuit breakers, AC breakers. And if it is direct current, you are going to buy DC breaker. Do not for any reason use DC breaker to protect an alternating current and vice versa. So now where I'm going to, which is the most important aspect of it, is in terms of let go voltage. What do I mean by let go? The let go voltage or current remains the value of current or voltage that you are permissible to touch in either AC or DC. As human being, our body has resistance, and the resistance of our body depends on the individual, the body of the individual. There is a particular part of our skin, which is the epidermis. In this epidermis, we have a particular component inside it called keratin. This keratin here will serve as a resistance. It serves as a resistance for the body. So it helps the body to develop a resistance against current, be it electrostatic or non-electrostatic current. But the value of this resistance depends on the value of the current that is flowing through the body. So if you touch a direct current and an alternating current, the value of direct current, the value of alternating current that your body feel is not the same value your body is going to feel if it is direct current. What am I trying to say? Let us look at what I put on the board here. I said maximum let go threshold voltage or current is 15 to 20 milliamps / 50 volts. The meaning of this is that if alternating current is flowing through your body, you have terminals of alternating current and you try to touch it. You can touch it conveniently. If the voltage is below 50 volts, you can touch it. Your body resistance can still be able to withstand it. Can be able to withstand it, and it will not circulate through your body. Resistance will be developed against it. But the moment the value of voltage rises to 50 volts in AC, alternating current, your body resistance will not be able to withstand the value of that voltage again. And when the current rises to 15 to 20 milliamps, your body resistance may not be able to withstand it again. In that case, the upper layer of your skin, which is your epidermis, will now serve as a dielectric material, which will now allow voltage and current to pass in that situation down to the lower layer. And in the lower layer, we have the sweat gland, and we also have the blood vessels. Both the sweat gland and your blood vessels constitute ions. And ions we are talking about are good conductors of electricity. So once the current gets from your upper layer of your skin down to the lower layer, which is the sweat gland and the vessels, blood vessels, this current flows through the blood vessels, through the hemoglobins in your vessels, throughout your body to the heart. The heart pumps out the blood again around your body continuously. And the moment that voltage is above 50, it is dangerous for your heart. And the current is above 20 milliamps, depending on the body of the individual. But once it is above 20 milliamps in alternating current, your heart may not be able to withstand it. And that could lead to the seizure of your heart. The heart may cease to breathe, and it could result to an eventual death. So which means, as an electrician, there are some of you who are set off, I can touch it. If you want to touch it, touching an alternating current depends on the following factors. Number one, the value of the voltage you want to touch. If the voltage is above 50, don't touch it. It is dangerous for your health. Number two, it depends on the resistance of the body. My own body resistance could be different from yours. So touching it the same way I touch it could pose a threat on your health. So number three is the length of time the body contacts with the current. If you touch fast, the severity may not be hard. It will not be so hard compared to when you touch slowly and you have a longer contact period. Whether you are touching fast or touching it slowly, it is not ideal. It is not recommended for you to touch a live conductor. Do not work on a live circuit. Switch it off. So if it is alternating current, do not touch voltage above 50 volts. No matter the length of time, it is dangerous to your health. Your heart may cease to breathe, and it can affect the pulse of your heart. So if it is direct current, let us see. Now, direct current, if you look at it here, we say 15 to 20 milliamps. But in direct current, you can touch 20 milliamps, 30 milliamps, 40 milliamps, up to 75 milliamps. And that is the threshold. Maximum you can touch. If you touch current above 75 milliamps of direct current, the same thing that happens in AC is going to happen to you. So it could result to a burn. Your skin may get burnt, and your heart could actually cease. Likewise, if you look at the let go voltage here, the threshold voltage in AC, it is 50 amps. Sorry, it is 50 volts. But in DC, it is 120 volts, which means you can touch current voltage below 50 volts if it is AC, and you can touch voltage below 120 volts if it is DC. Can you see the difference? Now, can I now ask you, between alternating current and direct current, AC and DC, which one is more deadly? You want to answer me? So let me just give the answer. And if you have any contribution, you can put it in the comment section. Alternating current and direct current, they are two different types of currents. And the severity of direct current is higher compared to alternating current. Although from 50 volts, you are going to feel the alternating current when you touch it. But direct current from above 120 volts is when you start feeling it, when it could have an effect on your body. So if you not think because this is 120 volts, you can touch it anyhow. If you are touch 120 volts and above for a long period of time, and you touch 50 volts and above for a long period of time, the severity of direct current will be higher than the severity of the alternating current. Why? The answer is here. If you look at alternating current, as it is flowing, it gets to maximum, it starts from zero, gets to maximum, back to zero, minimum, back to zero. So which means at some instance, at some point along the length of flow, the current ceases and becomes zero before it rises to maximum, back to zero, minimum, back to zero, zero to maximum, back to zero, and so on. But in direct current, it does not pass through any zero value. So the current remains constant. So that makes the severity of direct current higher than that of alternating current. So I want you to get that right. The severity of direct current, there are some of these solar installers. What they used to do is, anytime they are installing, especially those IPV inverters, that they need to connect like 6, 7, 8, 9, 10 panels together in series to generate higher voltage. The voltage you are generating in that case is above 50 volts. Sorry, it's above 120 volts. Do not touch the two terminals together. And there is another thing very important in this aspect. When you are touching the voltage, the terminal, the severity is less when you touch only the live without neutral and without any connection to the ground. That is why our fathers, when we were very young, they will tell you to go and put on your shoes anytime you want to press your iron. You want to press your clothes with pressing iron. The rationale behind it is that when you put on your shoe, and you know your shoe is going to serve as an insulator, if eventually there is a leakage from live to any metal body, it will only shock you. The reason why it shocks you and it will not result to death is because there is no complete path for currents to flow. When it flows through your body, if there is no exit for that current, so the moment there is no exit, that current continues to flow in your system, and at a time, the impulse will be sent from your brain to that body in contact with the live terminal, and the signal will be sent to the tissue controlling that particular part, and in that case, your hand will be, it's a reflex action. You will not think of it, but the signal will be sent there, and your hand will withdraw itself. So through a reflex action. But if there is a complete path for currents to flow, you do not put on your shoe and you mistakenly touch a live conductor, you will be grounded. The current continue to flow through your heart and grounded. So there is going to be a complete circuit, and that is more deadly. Whether there is a complete circuit or there is no complete circuit, if you touch some voltages, no matter the amount of insulator you are standing on, it is the insulation property will break down, and the current will still leak and ground you. So that is why it is wrong for you to take a decision of touching live terminals without any safety measure. Do not touch a live terminal. If it is compulsory for you to work on a circuit, isolate it. If you cannot isolate it, go and put on your safety gadgets that will protect you from having a direct contact with any live terminals. So I'm going to come your way next time. If you have any observation, please put it in the comment section. I'm going to see you in the next one. I'm Engineer Oxford. Bye.